So, today we are going through 13.2. We're working a little bit backwards. Most of it we've already learned, but I want to go through some of the word problems. So this is 13.2. Okay, so just a quick review. Remember, we have, once we get a quadratic alone, we can solve using the square root method. So when the quadratic's alone, we root both sides. When I take the square root of x squared, what do we get?
X.
We do not just get x, we get what?
Absolute value.
That's right, we get the absolute value of x. And what that enables us to do is have two solutions. X is equal to lose the absolute value, we set the other side equal to plus or minus. I can't remember who did this, but they did this accurate. So they had something like 2x squared equals 32. X, right? This is what they did. They divided by 2x. And it's accurate. Property of equality says we can do that, right? Mm-hmm. So then you're left with x equals 16. You with me? Mm-hmm. But we know better. When we have 2x squared with a quadratic, how many solutions should you have? 2. So I can divide by 2, but by dividing that variable out, I eliminate one of the solutions, right? Mm-hmm. Oh, sorry, it's 16x. Sorry, I can't go back and do that. Hold on. I can't do it that method. So I can do that, but then I'm still left with 16x. Okay, so we subtract 16x. I can't use the square root method here. Right? Oops, sorry. I was half asleep. Okay, subtract it, and we get x squared minus 16x equals 0. I factor an x out, and I'm left with x minus 16 equals 0. So x is equal to 0, or x equals 16. So what happens is, by dividing the x, right, you're eliminating one of your solutions. So please be careful with that. Got it? Okay. So remember, when there's a quadratic, your alarm should go off that there should be two solutions, unless it's a perfect square trinomial, is where you have one. All right, so remember, I'm going to go skip through this because we've covered it. If it's a non-perfect square, we still root both sides. We leave it under the radical. We leave it under the radical because it's more accurate. If it's not alone, we get the quadratic alone. That's the m squared. Whatever has the little square, that's the quadratic. So we get that alone, and then we can root both sides. Take the absolute value of m is equal to plus or minus rad 13. If we get something that's not in standard form, we get our quadratic alone. We move everything to one side. We're not going to standard form here. We just move everything to one side. Add 20. Divide by 3, my quadratic is alone. Now I can root both sides. Absolute value of y equals 4, so 4 is equal to y is equal to plus or minus 4. You guys remembering all of this? So quick little review. If we end up with a negative and I try and root it, all of a sudden that's where we say no solution. I can have a fraction. Take the square root of a fraction. We just can't leave a radical in the denominator. So I get the absolute value of x equals rad 3 over rad 5. Remember, you must rationalize the denominator. What does that mean?
You can't have a radical in the denominator.
You can't have a radical in the denominator, so you louder?
So you have to multiply it by you have to multiply it by the reverse of its.
Okay, what am I multiplying by? Not the reverse, yeah.
Multiply by rad 5 over rad 5.
By rad 5 over rad 5. I'm not doing it by rad 3 over rad 5, by rad 5 over rad 5. If I were to do the reciprocal,
Oh, yeah, that would. Yeah.
then I'd be left with a rad 3. I wouldn't get rid of any, I mean,
You get rid of everything.
Yeah, you just have one.
well, the problem is you can't just do this.
Yeah.
You would have to do it to both sides, and then you make more of a mess. So it's not the reciprocal. We're just getting the radical out. We're multiplying by rad 5 over rad 5, and then we get rad 15 over 5. Okay, and to lose the absolute value, it's plus or minus. So is everybody remembering this? Okay. When we have binomials, that quadratic is all alone. It's isolated. So I can root the binomial. And then I get the absolute value of the binomial equals 4. To lose the absolute value, I set the 4 positive or negative, and then I subtract 1. So we get negative 1 plus or minus 4. That's negative 1 plus 4, and negative 1 minus 4. So that's 3 or negative 5. Remembering how to do that? All right, so now we get to our word problems, I believe. Okay, height of a falling object. Take a minute and write these notes. Acceleration due to gravity is 5 meters per second. We don't necessarily need that. Generally, with these kind of problems, they give us the equation. Now, what these different variables, or the position that these variables are in, what they stand for. H is the height of the object. I always kind of like to say your ending height. Your ending height. Okay? Sometimes I would put that as your ending height. The T stands for time in seconds. And C stands for your initial drop height. So H, remember, is your ending height. And many times they'll switch this around, with the variables around, but at the same position, it means the same thing. So pause the recording and take your notes. Okay, so now we have a word problem. So this is like me standing on the, I don't know what happened to my quarter. Already lost it. Standing on a building, and I'm going to be dropping a coin. This is the exact situation, okay, from the top of a building, okay? So if, let's say I'm the building. I'm about 5 feet. Where would the 5 go? What is that?
Height.
But where does it go in that equation? C, the initial height. Now, usually on my PowerPoint, they're not giving the equation, but most test questions I've seen, they give you the actual equation. You don't have to memorize that. It's really just evaluating, knowing where to put things. They won't tell you what those things are, but they imply it. So in this case, it says, if a penny is dropped from the top of the Empire State Building, which is 448 meters tall, how long will it take to hit the ground? So what are they giving us here? We know H and C. What is the H?
0.
H, the ending height is 0 on the ground. So that was a clue. Do you notice they didn't say at 0 feet? They just say the ground. That is your ending height. And what else did they give us?
C equals 448.
48, okay? So I'm using that formula, and I'm going to substitute in the C is 448, the H is 0, right? And then I can factor it, okay? So we can subtract 448 from both sides, and then we can divide by -5. I know it's not going to come out even, but we end up with 89. Please, you're taking notes now. Okay? We end up with 89.6. So if I am going to root it, okay, I'm going to estimate the square root of 89 falls between what? 81 and 100, right? This is 9, this is 10. So 89, this is 8 digits away. This is 11 digits away. It's closer to 81.
9.4.
Yeah, 9.4, I would say. 9.4. And when I take the square root, it actually comes out to 9.46. So they're going to round it up to 9.5. So when I take the root of both sides, we end up getting about 9.5 seconds. Okay? Now, if I were to do that, like if I were to continue it, t squared equals 89.6, and we root both sides, absolute value of t is equal to, let's say 9.5. T equals plus or minus 9.5. Why are we not even writing it in my PowerPoint, the negative?
Because you
Oh,
can't
you
make
can't
it
have
negative.
negative.
Right, so that's why, because they can't have, and notice they're using the about, because they've estimated. Even if you take the square root on a calculator, you're still estimating, because it goes on and on forever, okay? When you take a square root of a non-perfect square. Okay, can I move on? Okay. Okay, you guys try the next one. Oh no, vertical motion. Okay, so for vertical motion is, the last one was, what do they call this? Height of a falling object, okay. So vertical motion is when actually something's moving up. So I take it, let's say I'm doing a firework, okay. In this case, that H is your object location in space, and the C is the T is the time, and the C is the initial height. But there's one more piece. When you have an object thrown upward like this, yes, you're getting velocity because it's being pushed, and it has the speed of, so it's going up and then down. That's vertical motion, up and then down. Makes that nice parabola, up and then down. Gotta get a new tennis ball off my husband. Does that make sense? Mm-hmm. So so in this case, we're just dropping it straight. But with vertical motion, we add velocity. So the initial height is here. I'm about 5 feet. Okay? So this is like maybe 3. Mm-hmm. So that's like a yardstick. And then notice I'm going up and then over. Okay? Up and then over. Sorry you can't see this in the video. Okay, we're starting at that initial height, we're pushing up, and then it's going to go up, reach the maximum, and come down. Okay, questions here? Okay, yes.
If H is the object location in space, what time is it? Like, is it the object at its highest?
Well, they can ask this in a numerous amount of ways. They can ask you what the height is, at a certain time. At what time is it the maximum height? The little v0, that means v sub 0, that's velocity at 0. Okay? I didn't know that. Science Academy taught me that. But that is what the symbol represents.
At 0 meaning like ground level?
Uh-huh. 0 feet per second. I think it's...
Zero
At 0 feet per, it's not at the ground, the speed is at 0. So starting here and then going. Okay. How long will the ball be thrown upward at 10 meters per second? Stay in the air if it is thrown from a 40-meter cliff. Okay, so how long? We're going to use the formula. What was the formula?
H equals -5 x squared plus.
The velocity times time plus c. Okay? What are we given?
The time of the starting height.
No, we're not given the time. It says how long.
The initial. Well, it says
Velocity.
from a 40
We're given the velocity is 10 meters per second. What else? What is the 40?
initial height.
The initial height, right. So, using the formula, the velocity is at 10, and we substitute those in. And my ending height is at 0. So, I'm doing, what are we substituting in?
40 for the
What is left to right? H, 0 equals -5t squared plus
10.
10 plus 10t plus 40. Good. And then we can, actually, we can divide both sides by 5, right?
Yeah.
And then we're left with 0 equals t squared minus 2t plus minus 8. Right? We can do our x marks the spot. What multiplies to negative 8 and adds to negative 2? Negative 4, positive 2. So that's t plus 2 times t minus 4 equals 0. So t is equal to negative 2 or t equals 4. What does that mean?
It's just 4.
It's 4. Right, it's 4 seconds. So the question is, how long will a ball thrown upwards stay in the air? It will stay in the air from the initial throw to the ground 4 seconds. Does that make sense? Mm-hmm. All right, here we go. Okay, why don't you try this one? Pause the recording and try this problem. H,
T squared.
so using the same equation, H equals negative 5 t squared plus the velocity times time plus c. Go. All right, so how long will what am I doing? Substituting. What is my H? 0. What is my velocity?
6.
And what is 8? C, initial height. Good. So remember, they're just drawing the diagram. And so when I substitute in, did you get this? I'm going to just divide by 1 so I don't have to factor. Now, when you factor, did you do your lead coefficient factoring or did you use quadratic formula?
I use quadratic formula.
Okay, so I'm going to do lead coefficient, I guess. What multiplies to, I'm multiplying by 5. What multiplies to negative 40 and adds to negative 6? Good. And so I get, remember it's t squared minus 6t minus 40, right? And so we get t minus 10. Can you guys stop? Times t plus 4. Whoops, that was supposed to be a parenthesis. But remember, when you're doing lead coefficient, we multiplied by 5, we have to divide by 5. So I get t minus 2 times, this becomes 5t plus 4. T minus 2 equals 0, so t equals 2. And 5t plus 4 equals 0. Subtract the 4. Right there, it shows us this can't be the answer. Why? Because it's a negative. So time is not going to be negative 4/5 of a second. So this is not the answer. So the time is 2 meters. It will be in the air 2 seconds. Okay, questions? You could have done, who did the quadratic formula? Did you get the same answer? Good. You could have done that too. All right, the last thing that we're going to do is annual compound interest. Again, here's the formula. A stands for the amount in the account, the total. P stands for principal, or your starting amount. R is the rate of interest, annual interest rate. So that means, what does annual mean? Yearly interest rate. And T stands for time. Pause the recording. Okay, let's try the next section. So I'm going to use the formula. Okay. If $500 is invested for 2 years and the interest rate is compounded annually, what is the interest rate needed to increase the total in the account to 540? So where would I put my 500? If 500 is invested for 2 years, that is your P, your principal. Good. So we're going to do 500 here. Got a 1. Okay, for 2 years, where does that go? T. It's the exponent. Okay, equals. Now, What interest rate is needed to increase the total account to 540? Where does 540 go?
A.
That's your A. Okay, and so what are we looking for? Our interest rate, okay? See how they did it. Now what would we do?
Divide both sides by 500.
Yep, we're in the square root unit, so we're going to get our quadratic alone. And then I have 540 over 500. Right away, we can reduce it by 10. It's 54 over 50. Then we can even reduce it further. 2 goes into 54 27 times and into 50 25 times. You guys with me? I'm going to just turn it around. And now what would we do now that our quadratic's alone?
Root both sides.
We're going to root both sides, okay? So as I root both sides, I'm rooting, I would root them separately, right? Rad 27 over rad 25. Because rad 25 is a perfect square.
How'd you get 27 and 25?
Because I divided 54 by 2 and 50 by 2. So now as I take the square root, what would this be? R plus 1 squared. It becomes the absolute value of R plus 1. And then we have rad 27 over 5. Okay? Now, there's two things you can do. You can reduce the radical further and then estimate, because we need a number here. We're not going to use this as we're going to have to estimate this down. In story problems, you have to estimate. So to lose the R plus 1, what does 27 reduce to?
9 and 3.
9 and 3. And that becomes what? 3 rad 3. Okay, that's how they're getting the next step. They reduce that to 3 rad 3 over 5, right? And to lose the absolute value, it's plus or minus. Now, I don't know, I'm kind of at some point you have to estimate. You could have estimated it at the square root of 27. But they're doing it here. Do you understand? So square root of 3 falls between 1 and 2. 1 is 1. 2, the square root of 4 is 2. So it's about 1.7. It's closer. I think it's 1.732. So 3 times, it's going to be the square root of 1. Sorry. Now I'm having negative 1 from both sides. So now what we have is 1 plus or minus 3 rad 3 over 5 at some point. So the square root of 3 is 1.732. Yeah.
Could you have reduced it and then subtracted the 1 from both sides?
Yes.
Okay, that probably would have been.
Yeah. It doesn't matter when you subtract that 1. So 3 rad 3, let's see what they're doing here. They're getting it right away. So usually when you're doing interest like this, you're always using a calculator. So the square root, if I did 3, I'm going to do, let me clear it, 3 times second square root of 3 is 5.196 divided by 5 is 1.039. So they're estimating it to 1.04. So do you understand what I did? In my calculator, I did 3 times the square root of 3, and then I divided it by 5. Do you understand? And that gave me 1.039. They estimated that to 1.04. So this is really negative 1 plus or minus 1.04. Does that make sense? You guys with me on that? So negative 1 plus 1.04 is what? 0.04, right? 4 hundredths. 0 and 4 hundredths. Negative 1 minus negative, it's negative 2 and 4 hundredths.
0.04 is impossible.
Which would be, interest can't be negative. So what is that as an interest rate? Because we usually talk about them as percentages.
4%.
It's a 4% was the annual interest rate. Now, my point being, instead of doing 3 times the square root, I probably would have just done at this point, I would have made this 5 and then the square root of 27, right? Because the square root of 27, let's do that. Second square root of 27 is 5.196, and then just divide by 5. Do you understand what I'm saying? You could have done it that way too. 1.039, same thing. You're getting the same thing. So I don't know that this kind of was like an extra step. If I know I have to estimate it, I might just estimate it here and then divide by 5. Does that make sense? Yes or no?
Yes.
All right, let's try the next one. Oh, that's it. Hallelujah. We're done. We're out.